Now recording. So, how's everybody today? Did you have a good break? Good. So, we are now in the second half of the semester. I am the person who will be shepherding us through, right through to the exam. I'll be the one grading your final. My name is Dr. Nicholas Moore. Some of you I've seen before, most of you I haven't. So I hope that we shall have a prosperous class together. I hope everybody learns something. So, is this a full section?
Yeah, there's way more people here, but a lot of people are in a previous class that goes right up until 3.
Oh.
So you'll get a bunch of people coming in soon.
Yeah, this is unfortunate. Who is it that's keeping you right until 3 then?
It's the digital thinking elective.
Digital thinking elective? You know, I know that according to the letter of the law of the schedule, you technically, it looks like you have right up until the hour, but you actually don't. Like, you are actually supposed to give the 10 minutes for people to get to and from classes.
Yeah.
Well, so it goes. So there's going to be, I was a little surprised because I was talking to Dr. Gilbert about, when we were handing off the class, and he said this was the good section. So, I was a little surprised to see attendance this low, but if that's the problem, then I guess it is what it is. But yeah, oh yeah, we talk. We professors, we talk. So, a couple of housekeeping items. First and foremost, you may notice the recording device. I am in the habit of recording my videos and uploading them to my YouTube channel for the benefits of posterity and any students who can't attend classes, would like to review a class, would like to review a class with captions, would like to review a class with captions at 2 times speed. Ah, yes. You're the stragglers. I know. The other class keeps you late, right?
Yeah.
Here, I just want to move my tripod a little bit this way so as to avoid. Here we go. If that's going to be an occupied row. All right. There we go. Let's see here. Adjusting the accoutrement. There we go. That's a little better. So, yeah, that's a little more healthy. Good. Wonderful. We were just having our introductory pleasantries. I'm Dr. Moore. I'm taking over for Dr. Gilbert. Yeah, I'm who you're stuck with. So, as I was saying, these lessons are going to be video recorded. The videos are published on my YouTube channel. The link will be published on the Canvas page, possibly today, probably not though, probably tomorrow, as this class ends at 5 and I have to get home to my wife and children. So the YouTube channel will contain not only our wonderful time that we spend together, but it also contains previous editions of this class and other classes that I've taught at this institution, and classes that I have taught at institutions other than this one. If you have any interest or curiosity in any other courses that I have taught, it is there for your perusal. If you would like to, skip ahead a little bit in Java, see what's coming in the coming weeks, there are previous offerings of Java available on the YouTube channel. Again, captioned. You can modify the speed. I hope that everybody gets some use out of it. Now, but still have to come to class though, okay? So, although this is quite a healthy group for this late in the semester actually, so you don't seem the type to skip class. Of course, the people who are the type to skip class would typically be skipping class, so there's, you know, it's a biased sample, but so it goes. So, if you're just watching the videos, you don't get to ask questions live. You don't get to interact with the lesson in that way. It's suboptimal. Highest bandwidth is still in person, right? Yeah. Any questions about that? Okie dokie. So I am given to believe that you folks left off at inheritance, inheritance being the next topic to be covered. Given that Tuesday was not a class, and usually would be, are we starting right from the beginning of inheritance?
Yes.
Okay, right from the tip top then. How'd you guys do on the midterm, the first one?
Pretty good. Pretty good.
Yeah, I'm seeing a lot of, sort of a medium to positive response. Good. Yep. We should probably talk about when the second one is then, just by way of like what's coming up in the course. So we are currently in week 8. Test 2 is occurring in week 10, so 2 weeks out. I'm currently in the process of finalizing the typesetting on the test. So, yeah, I thought I'd get it out of the way before all of the marking starts, right? So, in terms of test coverage, we are going to stop here. All right? So, this week is coverable on the test. Polymorphism, we are going to save that for the exam. Okay? Sounds fair? Okay, sounds good. So, let's talk inheritance. So, inheritance is a very important topic in object-oriented programming. Up to now, you haven't really, conceptually, we haven't stepped too far beyond the idea of a variable, right? When we talk about association, one class being associated with another class, we typically express that as a variable, instance variable within one class, giving a reference to an object of another class. So far, so good, right? If we want to get fancy, we stick those in an array, and then you can have a bunch of them, right? But your sort of basic implementation of that is just a variable, but the type happens to be a class, right? When we are talking about inheritance, we are talking about a horse of an entirely different color. Inheritance is an abstract concept. It's very difficult for people to understand on the first pass. Don't get all that if you don't get it the first time, right? Sometimes these concepts take a little bit to sink in. I will do my best to try to explain it as well as I can. So, the easiest way to approach it is with verbs. What is the verb associated with association? You guys remember? Association is a blank relationship. Fill in the blank. If you're talking about association, it's actually quite strongly unidirectional, if you think about it, right? One class has instances of another class, but it's not the same the other way around, right? So the verb is has, right? So any video game players out there? Good, good. So let's say I'm playing an RPG. Let's say I have a character, right? Let's say that character has equipment, right? You have an equipment slot. Into that equipment slot, you can put your great axe, your broadsword, or whatever weapon you want, right? The character class has a weapon instance variable that can hold a reference to an object of a weapon class, right? So, the warrior has a weapon, or has a reference to a weapon object. If you want to draw it out into very long Java talk, right? Something you may have noticed about Java is that it's very, very verbose in comparison to other sorts of languages you may have used before. Oh, there's a good survey. So, let's get the size of you. What languages have you guys used before? Any C++ people in the crowd? Python? How many people would consider themselves Python programmers, having taken intro Python programming? How many people have Python experience outside of that course? A couple of people, okay. JavaScript? A little bit, yeah. What am I missing? What do you guys got? Yeah?
C# in my station.
C#, that's a good one. So if you didn't know this, C# is sometimes called Microsoft Java because it's a dead ringer for Java, actually. Like just like Microsoft, right? It's like the term C# is primarily a marketing exercise, right? To make it seem similar to C++, but it's really not that similar to C++. It's not really a successor language to C++, as the name would claim. Whereas C++ is definitely the successor language to C. But in this classroom, knowing C# is a great advantage because it's very similar to Java in many respects. Any other C# programmers out there? A little tiny smidge. Anything else?
Bash.
Bash? Ooh, Bash is good. I actually, personally, most of the programming I've done recently has been in Bash, doing Bash scripts. Bash, extremely powerful, but really quite clunky. Anything else?
Lua.
Lua, are you writing mods for video games? How did I know? I actually don't know that much about Lua. It's kind of slightly Python-y, I guess?
Yeah, it's very similar, like scripting.
Yeah, cool. Any other languages? Right. Well, so, all right. So inheritance then. So where association is a has a relationship, inheritance is an is a relationship. So the verb is to be, right? So one class is another class. Now, knowing only that much, you may mistakenly think I'm talking about equivalency, right? Something something dot equals method, something something object equal to other object, object is other object. This is not the form of is that we are talking about. It's more like this thing is a member of that category, right? So when we are talking inheritance, we are talking abstraction, all right? So, here is an example. oranges. What are oranges?
Fruit.
Oranges are fruit. So, within Java, we would have a class for oranges, and we would have a class for fruit. Right? Fruit is the base class, orange is the derived class. What I just gave you there is actually the C++ terminology for inheritance. C++ prefers to talk in terms of base class and derived class, right? Something that's a bit more Java is to say one class extends another class. That's the keyword that we will be using in Java code itself to set up inheritance, right? However, from a understanding the concept perspective, I think base class and derived class make more intuitive sense. So, one important thing about the previous example. Are oranges the only type of fruit? Obviously not. There are many different types of fruit, so you can have many different classes which inherit from the base class of fruit. We can have a base class of fruit, and we might have several derived classes, apples, oranges, and cucumbers, all of which are types of fruit. In UML diagrams, we use a different arrow to indicate an inheritance relationship as opposed to an association relationship. So this is the arrow for association. Up to this point, this hasn't mattered. This has just been an arrow, right? But now we have an arrow with a full closed triangle on the end. Apples are a fruit. Oranges are a fruit. And cucumbers are a fruit. Now you may be saying to yourself, but Mr. Professor, surely a cucumber is a vegetable and not a fruit. But ha-ha! The technical definition of a fruit is something that contains seeds. So, cucumbers are fruit, in the same way that tomatoes are fruit. In the same way that squash are fruit. That's how fruit are defined. Although most people assign the category based on sugar content, which is actually an error. So, does that make sense? We are working in categories now. We are now no longer thinking of each class as being like some kind of specific, it's kind of weird to talk about physical objects because this is all virtual, right? But it's an object which could exist, right? All of the classes that we've worked with so far are things that you can actually produce an implementation of, right? You can instantiate them. When we get into inheritance, this may or may not be the case for things particularly higher up in the inheritance hierarchy. So, for example, let's talk about fruit once again. You can hold an orange in your hand. Can you hold the concept of a fruit in your hand? No. It requires more information, right? You can't eat the abstract concept of a fruit. It requires a specific, particular derived instance of that concept for you to physically interact with it. And this is even true if this definition includes physical properties. Right? So, and this is getting very philosophical, to understand the purpose of this class, we have to understand the purpose of a category, like the philosophical purpose of a category. So what is a category?
An organization tool.
It's an organization tool, yes. We are organizing different types of things, and we are saying that all of these things are similar in some way. Right? Can we drill down on that, though? In what way are all of the elements of a category similar?
They have like specific aspects that are the same among everything in the category?
Yes. I might refine that to say they share a set of properties. Right? Let's not worry about methods, let's just talk about variables. Aha! Properties are variables. So, let's say you're designing your Java program and you have several classes that are independent of each other, but they share a set of common features. Right? This is where you want to pull in inheritance, right? This is very different from the idea of association, right? So, let's see. So can anybody tell me what are some properties of the actual physical objects, apples, oranges, and cucumbers? What properties of all of these things are in common? Yes?
Weight?
Weight, yes. A fruit must have a weight because it is a physical object. What else do all fruit have?
Shape?
A shape, sure. How we define shape is a little bit, we'd need to drill down on that a little bit if we were making a Java program. But, for this type of example, absolutely. What are some other things that a fruit must have?
A color?
A color, sure. Blasted American spelling. There we go. I think you guys get the idea, right? So, when we define something like an orange, we pick particular values for these properties, right? Say the orange is, 250 grams, right? Spheroidal, right? Roughly a sphere, but not quite a sphere. Color, well, the color that it derives its name from, right? So far, we haven't seen an advantage to making a class inherit another class versus just declaring an object of this type and giving it some values, right? We don't need all of this complicated class-based shenanigans just to assign values to variables, right? So, where we start to see the value of inheritance is that this thing is permitted to have properties, this thing does not. You can add additional properties. For example, what makes an orange unique? Or, at least with respect to general fruit. Yes?
You have to peel it.
Sure, you need to peel it. So we might even give it a peel method, right? Because peeling is an action. Another thing that sets an orange apart from other types of fruit, it's made of segments, right? So number of segments is something that's relevant to an orange, but is not relevant to an apple or a cucumber, right? So we can add a new property, segments, to the orange, and that makes it a more specific thing, right? Whenever you're traveling from the top of an inheritance hierarchy down to, the lower things, you are always, always, always passing from less specific things to more specific things. So, in this example, it's, fairly obvious because it's a two-level example. But we could, if we wanted to sort of fill the diagram out a little bit, we could say, okay, so we've got fruit. There are categories of fruit that are not themselves fruit. Like orange itself is a category, right? There are many different fruit which people call oranges, whether or not that's an error, right? You've got navel oranges, you've got mandarin oranges, people will call clementines oranges. Basically any citrus fruit that is orange gets called an orange. Whether or not it's actually an orange is a different story, right? But you might have citrus. Citrus fruit are a type of fruit. Within citrus fruit, you might have oranges, lemons, and grapefruit as different types of citrus fruit, right? Within oranges, you have different types of oranges. Navel oranges, mandarin oranges, etc. Right? So these inheritance hierarchies can basically be as deep as you want them to be. Right? Normally, in the, for these type of lesson-y examples, like, this is a category that could be expanded quite substantially, right? Any one of these categories could be expanded quite substantially. And if you are working on a real-world Java program, that's likely what you're going to be doing, right? A very good, like if you want to sort of poke around in this sort of thing, a good example is Java's exception handling system, right? Exceptions within Java, we'll be talking about how to use them later on in the course, but Java uses exceptions, uses an inheritance hierarchy to organize different types of exceptions, right? So at the top, you've got exception itself, right? Under that, you've got runtime exceptions, and you've got compiler-based exceptions. Within runtime exceptions, you've got things like the type error that you get when you enter. When you guys did the console examples where you're expecting an integer and you put in a string and you get an error, right? That's one type of exception in that tree. Zero division error is another one, right? Is this making sense? So that's how Java itself uses inheritance to organize the various different types of things. Okay, sure. So far so good? But maybe, perhaps, we still are not quite sure why we would do this, right? Because this seems like quite a complicated thing. What is the purpose of all of this? The purpose of inheritance is the same as the purpose of association. It's the same as the purpose of functions itself. all of this is to minimize code duplication, right? We are trying to come up with an organizational scheme that reduces the amount of code that we have, the amount of code that we have to write, and the amount of code that we have to maintain and debug. The less code, the better, right? So consider it this way. Let's say there is a method which is common to all three of these different types of fruit. For example, eat, right? An action pertaining to a fruit. Eat. Eat. Probably requires more information than that, but you know, for this example. Since edibility is a property of all fruit, do you want to deal with 3 separate definitions of that method that all have to be separately maintained? Or would you rather collect them all up at a higher level in the hierarchy, have but one copy of that method, maintain that one copy of that method? Yeah? You guys, do I need to sell you on this? You guys seem like you're already pretty sold on this. Everybody sold on having their lives made easier? Good. It's like, I don't know, sometimes people like, basically my job and this course's job is to take all of you people who, in theory, should have become quite comfortable with if statements and loops back in Python, and basically try to, like, you know, encourage you along to the next step of learning how to program. Because, you know, you can actually do quite a bit with just if statements and while loops, right? Like, it is unfortunately the case that a lot of people get to that level, become comfortable with their existing set of skills, and never progress beyond that. And you know, that's okay if you're a person whose job does not really involve programming, but you know, knowing a little bit of programming helps a little bit. You know, I'm thinking of like mechanical engineers who have to do a little programming for research or whatever, and they never really learn programming, but they can cobble together some if statements and while loops, right? If your goal is to be a computers professional, as I assume it is the goal of everybody in this room, you need to not stop your skill developing at such a low level, right? You need to continue to develop your abstraction mechanisms, right? So that's what this is. Does this make sense? Any questions? All right. So this is kind of a strange little example. So I'm mostly interested in the UML, to be honest. On a side note, I absolutely hate UML, as I'm sure all of you do. Probably for a different reason though. I hate it because like there are literally like actually 10 different UMLs, right, all pertaining to different problems, but they all get called UML because once you call something universal, you have to use it everywhere, right? But anyway, so in this example, we have a wug. A wug is a bird. It gives some resemblance to a bird, at least. So a wug is a bird. A bird would have feathers wings, flight, etc. We're not sure what the properties of a wug are, except maybe bluishness. A bird is a type of animal. Animals have methods like sleeping, moving around, dying, reproducing, stuff of that nature. By the way, what's a method that a bird would typically have that an animal doesn't?
Flies.
Flight, sure, except in the case of certain birds, of course. See, that's the problem with categories in real life, is like, it doesn't matter how you draw your categories, there's always going to be something that falls outside of it, right? It's kind of like the sandwich debate. You guys know the sandwich debate? Define a sandwich.
Bread,
Bread and meat,
meat, burger.
like a hot dog.
I mean,
So-
bread, meat, bread.
Bread, meat, bread. Okay. What about a cucumber sandwich?
Oh,
Right?
would that be cucumber, something else cucumber?
Well, no. It's like bread, cucumbers, cream cheese, and bread. I believe
Yeah.
your basic cucumber sandwich. So no meat. So your definition fails. Right.
Oh.
Right? So basically, if you drill down in the definition of a sandwich, you'll find that every single element of a sandwich is optional. So you can define like all and no, you can define everything and nothing as a sandwich. Right? So for example, if you go to some of these fancier burger joints, you know, like the hip burger joints, they can serve you a hamburger on like 2 halves of like a lettuce head, right? Is that a sandwich? It's certainly playing the part of a sandwich. It would be a stretch to say that that is not a sandwich, right? It has all of the elements of a sandwich except the bread. The bread has been replaced with lettuce, right?
And
Yeah.
what's the agreed definition of the sandwich?
There is none.
Oh. Okay.
That's the whole point of the sandwich debate. That's the reason it's a debate, is there's no agreed upon definition for a sandwich,
Alright.
right? Because there are so many exceptions to what a sandwich could be, right? People will make the argument that tacos and burritos are sandwiches, right? But you can get there by mutating the definitions, right? So, you know, that's the problem with categories in real life, is there's always going to be an exception to your category. Fortunately, we don't have to worry about real life. We are programmers. We only have to worry about virtual life. So long as the ones and zeros are satisfied, we are happy, right? So, when you design a category structure inside of Java, it may not be violated. It's actually enforced at the level of the type checker. You guys know what the type checker is, right? Aside from the thing that checks the types.
Is that the data type checker?
Yeah, so it does a lot more than just check types, but basically part of the Java compilation process is that it runs through a set of routines which perform static checking on the code without executing the code. This is type checking, but it does other things besides. When you hit basically, when you're talking about trying to compile your junky code, there's, not yours specifically, junky code in general. There are like a couple of layers that you'll hit typically. The first layer is syntax, right? If you've forgotten a semicolon, you'll fail at like the first layer of the compiler. It won't need to go any further. It's like, fix the semicolon please, and it kicks it back to you. The next layer under that, roughly speaking, is type checking. So it checks to make sure that the operations you're performing are consistent with the things you're performing them on. And that's what the type checker is for, right? Now, was the two-stage nature of Java explained to all of you?
Compiling and then running?
Yeah,
A little
but
bit.
a little bit. Would you let's do a review. This is just what this class is going to be like. So everyone's using IntelliJ, right?
Yes.
So IntelliJ hides this fact from you, but do you folks know the difference between the Java runtime environment and the Java development environment? This is something you should know if you've done a course in Java. So, let me teach you. Java is two programs, the Java compiler and the Java virtual machine. Some of you who know Java from other places have likely heard the term virtual machine before, right? So, if this is your operating system, you have the Java compiler. This is called Javac, Java with a C, Java compiler. And you also have the JVM. This is also called just Java, if you're doing a command line invocation. So, when you write your Java file, right, hello.java, right? The first thing you do is you compile it using Javac. IntelliJ is doing all of this for you, but if you're ever to use Java in a non-IntelliJ context, you should know this. In goes hello.java. Assuming it's not completely broken, out comes hello.class, a .class file, right? If you poke around inside of the project directories inside of IntelliJ, you will find a bunch of class files. You will probably have wondered what they were for. They are post-compilation files that are not binary files. Most compiled languages, such as C or C++, at this point will give you an executable file in windows.exe, right? You can run that directly on the operating system. But Java is both an interpreted and a compiled language. You guys know the difference between an interpreted and a compiled language?
Only a little.
A little bit? Yes?
Is it because Java is like a different, like it really is a code that we can understand, and then it has to be translated into a form of code that we can, which would be the Java language itself.
So, do you know what it has to be for the computer to run it?
Machine.
Binary or machine code. That's right.
Yeah, machine.
Yeah. So somehow, somewhere, your code has to be transformed into machine code. Right? Now, the machine code is produced directly by a compiler, other than the Java compiler. So you can just load that binary code up, run it directly on your operating system. Bob's your uncle.
Why don't we, why is the setup where Java, then from Java to machine code to actually running the function or whatever, and not just removing the machine code itself and making the machine read Java?
It has to do with the structure of the CPU, right? So think about what it means. I unfortunately I don't think I can answer that question quickly enough to give you a good answer to it, because my brain's well, what if I explain about how electronics work? I can't explain about how electronics work within this context, unfortunately. But suffice to say, within the circuit that is the processor, certain binary digits, combinations of binary digits, activate regions of circuit that do things like plus, minus, shift left, shift right, right? That has to be binary, right? No matter what language we're programming in, ultimately everything must be executed on the CPU itself. The question is, how do we get there? With a compiled language in the normal sense, it just produces the binary code that can be executed directly. One of the advantages of this is speed. One of the disadvantages is you have to recompile for your CPU. But in the old days when we used to, load up your CD-ROM and install your program, that's what it was doing. It was taking the source code, compiling it for your architecture. However, Java was one of the pioneers in this. If we put a software process between our code and the operating system, it can convert our code to binary code on the fly at the time of execution, rather than all up front. Disadvantage, speed. This is much slower than compiling it normally. Advantage, you can do all kinds of interesting and fancy runtime checks that you can't do if it's just compiled. For example, garbage collection. You need an interpreter process to do that. So, in Java, we compile to a class file using JAVAC. This then needs to be run on the Java virtual machine. So, the Java runtime environment, JRE, is just the virtual machine. The Java Standard Development Kit, SDK, is the compiler and the runtime environment. Does that make sense? So far, so good? Good. So, let's talk a little bit more like Java-y examples. Well, no, let's not do that. We'll do a minimal example of what inheritance looks like in Java code, and then we'll worry about geometric objects. Okay? So, if everybody could please load up IntelliJ at this time. There we go. Window, where is it? Oh man. It's actually been like over a year since I taught Java, so I've forgotten where dark mode is. Where's dark mode?
Click on IntelliJ and then settings.
Sorry, click on IntelliJ.
Yeah, like that. I mean, this is on my Mac though, so maybe it's different.
If you go
Yeah.
files,
File settings.
file,
So, there it is. And then here-
Appearance, there we go. Darkula. There we go.
Ooh, you'll probably have to dim the lights there.
Yes. Well, I was going to have to do that anyway. Boink. There we go. All right. So inheritance then. Let's stick to this. So let's first make ourselves a simple little class for fruit. Okay? So, source new Java class. Give this class the name fruit. There you go. Public class fruit. I'm not even necessarily concerned about constructors here. So, let's give ourselves, yes, sorry? Oh yeah, sorry. Is that good? There. So, properties of fruit. Private, double, weight. Sure. Private, string, name. Private, int, seeds. As all fruits must have seeds. Generate ourselves a nice little constructor right there. Oh, not that. Excuse me. Constructor, all of them. There you go. I assume that Dr. Gilbert showed you how to do that one. Good. Very good. A nice little fruit class. Now, let's make ourselves a class, new Java class, oranges, or just orange. There you go. A class for oranges. So, in Java, the way that we declare one class as inheriting from another is using the extends keyword. Orange extends fruit. Yes?
Wouldn't we extend it to the main method for sure?
Is an orange a type of main method?
No.
Then no. Does that make sense? So, what the main method is going to end up doing is creating a couple of orange objects, probably within public static void main, right?
Mm-hmm.
That's an association relationship, right? Here we are saying oranges are a type of fruit. That's an inheritance relationship. So, in actual sort of brass tacks, what I've just done, once I fix that error, what I've just done is I have taken all of the different components of the fruit class and I have smacked them in to the orange class without having to redeclare them. Let's just fix this error. There is no default constructor available in fruit. So, the thing that it's complaining about, when you inherit from another class, in this class's constructor, it calls the constructor of its base class in Java, right? So, can anybody tell me, do I have a constructor here?
No.
Trick question, yes I do. Java puts one in by default. If you have not specified a constructor, Java puts one in that takes nothing and does nothing. Right? And you get that by default. What it's complaining about right now is that this constructor that doesn't exist, that it adds in itself, it's attempting to call as the same constructor in the fruit class that actually doesn't exist. So, in the fruit class, yes, I know I have related problems. How do you stop a Java class from inserting the default constructor? You provide your own. Because I have defined this constructor here, this class no longer has the default constructor that takes nothing and does nothing. Does that make sense? We have overridden the default constructor. Well, it's overriding means that something a little bit different. It's Java. Words. We have replaced the default constructor with one of our own. So, this guy, his default constructor is attempting to call the default constructor of fruit. That doesn't exist anymore. That is why we're getting this error. There are two ways we can solve it. One, it's simple enough to put basically the default constructor in ourselves by overloading the constructor, right? We can do that easily. Alt insert constructor taking nothing. Okay, baboom. Public fruit. You can see our little error goes away, right? The default constructor here has now found a definition of the constructor, taking no arguments. It's no longer calling something that doesn't exist, so it's happy. Does that make sense? So you see how this can be a little bit tricky?
What's the other way? You said there was two ways to solve that.
Yes. The other, and this is actually the preferred way. This is kind of the way that I just showed you is the very like, oh yes, Java, I'll do what you want. Please don't hurt me with your compiler. That's what that solution is. The solution where you're the boss and you tell Java what to do is you define a constructor here that plays nice with the constructor you defined previously. This is the better solution, right? So, I wonder how intelligent the automatic generator is. Pretty intelligent. So, in the same way that our fruit constructor needs weight, name, and seeds, our orange constructor also needs weight, name, and seeds. It then passes these to something called super. This is not a pun. We're not making soup, right? So superclass, subclass. Important terminology. All right? So, in this case, the fruit class is the superclass of the orange class. When we use the super keyword, we are invoking the constructor of the superclass. This must be done on the first line of the constructor. It's very similar usage to this. You guys remember the example of using this to deal with overloaded constructors within the same class? It's a very similar idea. Super works a lot like this. It pops you up one level in the hierarchy. Does that make sense? So that's how you pass information up into the constructor for the superclass. Any Any questions? Yes, sir.
On your example you had before where you had like multiple levels, would you just have a super in like each level, or would you have multiple supers in one?
You are legally only allowed to have one per constructor. So, yeah, I erased it. Where we had fruit, citrus, orange, orange's super would refer to citrus. Citrus's super would refer to fruit. And this is actually like, it's kind of weird to say, but like, orange kind of in a way shouldn't know that it's a fruit. It should know that it's citrus, and citrus should know that it's fruit, right? That's kind of like decoupling your concerns as you go through the hierarchy. Does that make sense?
Yeah.
Yeah, okay, good. Yeah, these are very like Java ways of thinking. Yes.
So super is like, essentially it records the weight given seed in fruit.
Yes.
For orange.
Yes. So I'm going to attempt to correct thinking once again. So a lot of you may be thinking like this. We've got fruit, we've got weight, right? Now down here, we've got orange, and we are accessing weight, right? This is like partially true, but a better way of thinking of this is to think of it like this. You guys get the difference? So, orange is now the interface layer to fruit, right? Fruit should never be directly accessed from outside. You should always have to go through orange to get there, if it's an orange object, right? Like, the subclass, in some sense, packages the superclass. It forms the outer layer, right? It forms the API, right? Make sense? So far so good? Good! So far this class has only had intelligent questions, so I'm very happy. Okay. So it goes. Now, let's play with this a little bit in a main class. So, let's create a main class, please. Oh, 404 time not found. Let's make a new class. Call it main. There we go. What's the default? Is it PSVM tab? No. Is it main tab? There we go. Main tab. There you go. PSVM is how you abbreviate it on the test. Public static void thing. There we go. You see what I mean when I say Java is a verbose language? So, Java is a verbose language, but I hope that at least some of you in this room will kind of develop a bit of Stockholm syndrome for it. Although it's very verbose, almost everything that Java, aside from inserting constructors and that sort of thing, almost everything it's doing is right there on the page, right? This is in wild contrast to JavaScript, which is the worst language imaginable. It's even worse than Python. I was disappointed to find out it's even worse than Python. Oh man. But, I just kind of generally hate interpreted languages. So, let's declare some oranges. Well, let's declare a fruit and an orange. Fruit, fruit, foo is equal to new fruit. There we go. Kind of threw me off for a moment. You need stuff. Weight will be 6.5. Name is ugly fruit. Actually, that's spelled with an I, right? There we go. Seeds, 17 seeds. There you go. Now let's do an orange. An orange called bar. New orange. Weight 2.3. Name is Thomas the orange. Seeds 5. Low seed count on this orange. Well, actually, that's pretty high for an orange. There you go. So we have 2 objects which have been declared. Yes?
There's something I've been thinking about. For example, if I understand that the fruit is important because it sort of gives structure to if you're going to add more fruit down the line in the program,
Yes.
that gives it a full, like, something to follow. But
Yeah.
if we're just doing orange right now, do we still need fruit in our program?
No. Everything we're doing is completely pointless unless we have multiple types of fruit.
Okay.
We could very, very easily package up the stuff that's inside of fruit and put it inside of orange, right?
Yeah.
A traditional point of annoyance with me with respect to the slides, and they're not even slides, the teaching materials in here is like, most of the time when they do inheritance inside of the notes, they do it, like, in my opinion, badly, because, like, all you would need is like one string variable indicating like a type, and you wouldn't even need the inheritance hierarchy that they're talking about in the notes. I'll point this out when we come across it.
Yeah.
Right?
And also, I was also thinking, why do we need super if we're already extending to fruit?
Super is not necessary if you have no data to pass back to the super class's constructor. But if you have data to pass back to the super class's constructor, super is the only way to do it.
Okay.
Good. So we've got foo and we've got bar. If we print, what's the abbreviation? S out. There we go. S out. Print foo dot weight. Can't. Is it private? I'm going to make this public. Just for the purposes of demonstration, I shall make the variables public. There we go. Foo dot weight. There we go. S out. Bar dot weight. So you'll notice something here. I don't get any compiler errors for doing that. Question? No? Some of you who are like still thinking in an association kind of a way might be thinking, well, obviously what you would need to do there is like bar.fruit.weight, right? That would be a very JavaScript way of doing this. But no. Remember, orange is the outer interface. Any public elements of fruit are migrated to the new boundary. So we have direct access to any public members inherited from the superclass. We can just use them. Methods too. Does that make sense? If we execute our program, save, oh man. I remember how to do this. Right click, run main. There we go, that makes it go up there. And it's doing stuff, parsing. There you go. I remember this class. There you go. Foo.wait, bar.wait. This is valid syntax. Does this make sense? Good. So let's do something with orange, because once again, like, there is no point to this, right? It does nothing except invoke the superclass. It needs something that distinguishes it from fruit. So let's give it a public, and public, don't use public, we're going to use it for an example. Public int sections. You can even add that to the constructor if you wish. There you go. Now in main we need to provide a number of sections. How many sections typically in an orange? Oh, let's say 8. Probably 10. There we go. Now, if I ask for bar.sections, that is a thing that exists. If I ask for foo.sections, that is not a thing that exists. Make sense? All of these rules are also applicable to methods. Any questions? Yeah.
If I add a property to the fruit class, would all the constructors down the line will get updated, or do I have to update them?
Well, it depends on how you add it. If you, let's say we add public double location, sure, right? If you add it in such a way, this dot location is equal to 0, you provided a default value, right? Your interface hasn't changed. So nothing in any subclass has to change. If you want, you can also, maybe using auto magic, throw in a constructor which includes the location, overloading it with the original definition, right? This would give you the ability to set location in the constructor, a generally useful thing. As long as you don't destroy that definition, anything which is using, anything that's using it doesn't break, right? You start running into trouble if you replace this one with this one. That means that you have to update all of the constructor calls throughout everything else to use the new version of the constructor, which can be quite the pain in the keister, but IntelliJ at least will give you like an itemized list of everywhere you need to make that change. So it's, you know, it's not as painful as it might be to make that kind of change. Does that make sense?
Yeah.
Very
If you
good.
go to the orange class now, is location going to be in the constructor inside the orange?
No.
So
I
you
have
to
a
add it
related
there
problem. Oh yeah, that's that is a problem. Let me fix that. Yes. So in this case, right? Orange is not setting location. Orange is not receiving it, and it's not setting it. The super method, which is invoking a constructor in the superclass, is now invoking the one that takes 3 arguments, not the one that takes 4 arguments. So it will use the default value for location. This is quite, you may, you know, history doesn't repeat itself, but it rhymes, you know? This is fairly similar to the way this works. Make sense? Very good question. Any other questions? Yes, sir.
Since like if you print your bar dot sections here, it would you have to add this dot sections equals sections just to set the value of orange?
Bar does not exist in this context.
What on your main, if you do
Yeah.
the main, if you do your bar dot, if you go to print your bar dot sections with the value passed, would that print that, or would you have to include like this dot sections equals sections, like set that as?
Oh, I see. Yes, yes, actually you're right. Yeah, sections is being lost. It's being passed, but it's not being assigned.
Yeah.
If I had bothered to run the code, I would know that. 0, right? So yes, in addition to super, you also need this dot sections is equal to sections, which assigns the passed value to the instance variable of this class, and there you have it. If we rerun the code, we get the value that we assigned. Make sense? Everybody, you've been following along with the example well enough? Good.
Did you do an example where we're actually assigning values in the console?
In the console?
Yeah, for example, like there's where like can you do an example where there's like a user who's actually assigning value to for example orange, weight, name, like and stuff like that.
I could obviously, but like setting up a user interface is like time, and I'd rather continue on with
Okay.
this material. It works the same way as you've done previously. The only because these are public right now,
Mm-hmm.
I can just do stuff like, you know, bar dot sections is equal to 11. I can just do that, right?
Yeah.
What you should do is you should make them private, and you should make setters and getters, in which case you replace this with a setter, right? But up to the point of like if you want to put it this way, the user interaction section and this part to do with the classes is like, it's, the interface is the call, and that is very simple. So if you know how to do user interaction already, it's quite easy to plug the results of that in.
Okay.
Cool. Any other questions? I appreciate, I want to do that example, but we need to keep rolling.
Yeah. And just to let you know, I don't think module 8 is public right now on our side.
Ooh, that's something that should be fixed forthwith.
Or week 8.
We are week 8.
Yeah.
You are absolutely correct, sir. Oh, that's week 9. See here, week 8. Publish module only, so that you don't get the solutions. Solutions shall be released at the end of the week, I guess.
Wait, what if we're working on it tonight though, and we want the solution?
No. Assignment 5, huh?
Actually, I was gonna ask you,
It'll
assignment
only-
4 is due tomorrow. It was released during reading week too.
Let's take a look at it. Let's take a look. Assignment 4, graphical user interfaces.
Sure.
One thing at a time. So, this is a lot less. Okay, so this has changed versus previous. Okay. There's nothing in there that you shouldn't be able to do. That being said, given that the due date is tomorrow, Monday? Can we get it done by Monday?
Sure, it's better than tomorrow.
Better than tomorrow?
Friday sounds good.
It's already due Friday. There we go. We'll make that due Monday then. That'll give you the weekend. Okay?
Okay, so no solution now?
Listen, I will not have sedition in the ranks. I'll release this, there is actually a reason, alright? You should work on, if you have these I know that this is no longer really a thing because of the accursed chatbot, but when you're working on practice problems, you should not have the solutions. You should have the solutions only after you're finished working on them. Because if you see the solutions, it will bias your solution, right? If you're stuck on something with respect to the example problems, I'd much rather you send me a quick email about it. And I can give you a pointer or two. Because if you see the solution, it's like, if you were doing an assignment and you saw a solution to the assignment, right? Human beings are very highly suggestible, right? Once you've seen a solution to the problem, it's much more difficult, like an order of magnitude more difficult to come up with a different solution to the problem, right? So that's the reason. I will release them in 1 week.
Awesome.
Okay.
And also, I was wondering, we're for task 2, it would be what, in a week from now or 2?
2 weeks.
2 weeks from now, are you able to, not the solution, just the problem, so I can start working on it? I like working on things ahead.
That's a reasonable request. There should be some practice material in the modules.
Yeah,
which
if you
can
can
be released.
release just the practice right now.
Yeah, the review stuff. Yep, that's reasonable.
Awesome, thank you.
That's reasonable. What am I gonna do? Discourage students from preparing for the exam early? Right? So according to psychology, this is the ideal studying method for human beings, right? You may have heard that cramming is bad and doesn't work. This is true, right? What you're trying to activate is not your short-term memory, but your long-term memory. If you take 10 or 15, maybe 20 minutes a day, every day, and you study for the week or two before the test, that puts it into your long-term memory rather than your short-term memory, which means that it's not only there for the test, but it's also there for the exam and your goddamn career, right? That's much better. You should approach this material like you're practicing a musical instrument, right? It's the same kind of mindset. Now, when you're doing your studying, there are more and less effective ways to study. The least effective way of studying is to read the material, right? You want to read the material and then perform a recall exercise, right? When you are being tested, you are not being tested on reading, right? I don't just give you the test and say, here, read this, and you say, okay, I'm done, and you get 100%. That's not how tests work, right? You read the question, and then you have to recall information from that lovely, fancy, neat computer, right? You have to recall the information, apply it to the situation, put it on paper. The closer you can simulate that process, during your studying, the better you will have studied, right? So, whenever you're studying, always, 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 always include a recall exercise. If you want to do it really effectively, perform a recall exercise at the beginning of your session from the stuff you studied yesterday. That will really activate the long-term storage, right? There are, as for what recall to do, there's lots of different ways to do this. Quizzing other people on the material is one way of doing it. Answering a problem is another way of doing it. When you're trying to memorize notes, first of all, you shouldn't try to memorize notes. You should try to understand what the notes are saying, right? Memorizing notes is a bad way to pass an exam. I think that creating point form notes, assuming you're doing studying on your own, summarizing the material is one of the most effective ways of studying material. That's the way I typically learn stuff. So that's what I recommend. So, if you are the type of person who has become accustomed to using the accursed chatbot to summarize things for you, you are actually using it to rob yourself of the best studying you will do while you're studying. It is collecting the information into the meat organ, sifting out what's important, making decisions about what's important, and putting the important stuff down on paper. That is the hard intellectual work that will make that information stick inside of those meat folds. Does that make sense? So, those are my studying recommendations. Some people study more effectively in groups, some people study less effectively in groups. It's all up to you. You are just, keep in mind that your friends are not necessarily the best people to study with, you can, if it works, great. If it doesn't, don't do it. Do what works, is my advice. Any questions? Alright. That and take fish oil. That's my other piece of advice.
Does
Yeah.
that actually work though?
Yes. Yeah. My wife got me onto the fish oil about a month ago, and yeah, it works. It's good. It improves cognitive function. It does. And it's not a drug, and you can't get addicted to it. It's just think about it this way, right? If you're running a motor on a car, and you're using the wrong kind of motor oil in it, the engine just has to work harder to do the same work, right? It's the same thing with biochemicals, right? You're just making yourself do more work for the same ends because you don't have quite the right chemicals available, right? So, omega-3 fatty acids, I highly recommend them. Yeah. So, good. Anything else pertaining to the course while we're on the subject? Yes.
I don't think we can see your information on the.
Oh yeah, I haven't updated it yet.
Oh, okay.
Yeah. I'll do that tomorrow. I'll do that at the same time I put my YouTube channel up on there. Okay. Now comes the point in every class where I look back through the module and see how far I actually and what I covered. You may get this impression from me, but my approach to doing these classes is I follow the course through the material that I think makes the most sense. That may not be the strict order that things are presented in here, but I will teach you everything that is in here. Okay? That is my promise. Unless I say this is important and this is unimportant and not on the exam, in which case something is unimportant and not on the exam. Alright? So, an example that has been running through the course material so far is geometric figures in Java FX, right? You may even be sick of them by now, but you can say goodbye to Java FX when you graduate. This class at least. As far as I'm aware, nobody uses Java FX ever for any reason except here in this course, but that's okay. Most people use a different Java library called Swing. But that's okay. It does basically exactly the same thing. That's okay. So, if we consider circles versus rectangles, within the context of a Java FX like object, circles and rectangles share many common properties. They share many common properties because, of course, it's highly similar to the SVG graphics stuff that you've done in JavaScript, because that's the actual back end of it. Are you guys concurrently taking JavaScript? Yes. Is this like, is this a section of like, are you guys winter start people?
Winter start, yeah.
Yeah, okay. Cool. Generally speaking at least. Yeah, so you guys will be taking JavaScript. It's kind of interesting how like this course and JavaScript kind of like meet in the middle and then go off again. Like, when you're doing SVG, it's like, oh, feels a lot like JavaFX. When you're doing JavaFX, it's like, oh, this is a lot like SVG. Yeah, it's because they're the same backend, right? Anyway, your properties of SVG objects / JavaFX geometric objects include things like X and Y position, things like the stroke color versus the fill color versus line width. These are all things that are in common among these two very different forms of geometry. Circle and rectangle have their own things. Radius is a property of a circle. Radius is not a property of a rectangle. Width and height are not properties of a circle, although they could be, but not in this case. We are choosing to define the size of a circle according to its radius. This is the way that you would do an oval, right? Well, I think this is the actual way that SVG does ovals, but, nevertheless. You can see that both circle and rectangle inheriting a base class called geometric object, it allows us to write significantly more compact circle and rectangle classes, right? You can imagine how much worse this would be if I had to take all of this stuff and cram that in here and cram that in there, right? We would have, two very large classes with a lot of duplication instead of one large class and two tiny little classes, right? You may have noticed in Java that many of your methods aren't very long, right? This is actually like, this is a good design heuristic for Java. It's kind of a good design heuristic in general, but for Java specifically. You should always view the number of lines of code in an algorithm as like the size of the available area for bugs to live in, right? So the shorter it is, the less space you have for bugs in it. So as long as you're using your methods correctly, you know, and because you're being helped by the type checker in that respect, it's somewhat easier to pick up those types of errors than logic errors using if statements and while loops. Small is good.
Would you
Right.
say like the number of lines of code will be an indication of how like efficient the code is?
In a lot of cases, yes, actually. I have my favorite little anecdote from when I was teaching at McMaster University. I used to teach C programming, if you can imagine such a thing. And I had an assignment question where it was like, use string, a little bit like the format tag, or the format operation in JavaScript, but a similar thing exists in C. You can use format tags in strings to do various things with printf, like, you know, space this out by so many things. There's an option for that, right? I had a student come to me who said, I'm very frustrated with this program. I don't know where the bug is. Can you help me? This is a problem that, like, my instructor's solution was like 8 lines of code, right? The file they showed me was 120 lines of code. And it's because they weren't using any of the stuff that we talked about in class, right? They were trying to do the whole thing with if statements and while loops. So I said, you know, I would love to help you with this program, but this is so long, it would take me probably a couple of days to find the problem in it, right? Even me. And so I said, listen, there comes a time when you take the paper ball, you scrunch it up, you throw it over your shoulder, and you start again. This time you use the stuff that we discussed in class. But like, the thing I try to illustrate there is like, if you take a relatively simple operation and you blow it up to that degree, you're going to make mistakes. You're going to make mistakes that are hard to find. If you keep the code small and compact, there's just less surface area for bugs to grow on, right? It's a good design heuristic. Now, that being said, everybody in this room is like, with maybe, you know, stochastically speaking, maybe 1 or 2 exceptions. Everybody here is like probably a novice coder to an intermediate coder at best, right? Otherwise, why would you be going to school for this, right? It is not my expectation that at this stage anybody is writing any fairly compact code, right? To some extent, you need to write stupid long programs, right? Because you need to get the experience of doing that. The way that you come to, like, writing compact code is primarily through experience. And you need to get the experience before you get there. Back in my days when I was taking kung fu classes, my master said, yeah, my master said that there are 3 beginners, 3 masters, and 10,000 adepts, right? So like when everybody starts, everybody programs similarly because everybody knows nothing. As you gain experience, you'll develop your own coding style, right? The 3 novices become 10,000. As you gain more experience, you'll start snipping off the bits that don't do anything. You know, this would be a little more efficient if I did this. This would be a little more efficient if I did that. By that process, expert programmers gradually come to resemble each other. because they all snip off the same bits and are left with like the core stuff, which is very highly efficient. Does that make sense? So right now, you should be in the expansion phase. You should be developing your own style of coding, which means it's not going to be the most compact code, right? That's fine. That's the stage you're at, right? Don't expect yourself to be an expert programmer, because you're not an expert programmer, right? You can't just snap your fingers, you can't just, oh, I don't know, type a problem into a certain prompt and become an expert programmer. That's not how it works. The only thing that you can do easily is be wrong, and that's hardly worth the effort. So back to this then. Let's go through these points quickly. You can think of this as review of the concepts that we've talked about today. The arrow means is as opposed to association, which is as Circles are geometric objects. Rectangles are geometric objects. You would kind of like expect the arrows to go the other way, right? Like the thing at the top points to the things below, but that's not the case. The arrows are the reverse of what would be intuitive. The circle class extends the geometric object class. This is the subclass. This is the superclass. This is the derived class. This is the base class. This is the child class. This is the parent class. Right? Several pieces of terminology are used for this relationship interchangeably, depending on what language that you're talking about, who you're talking about to, what day of the week it is, who you work for, and what the position of Jupiter is relative to Saturn. The circle object contains all of the fields and methods of the geometric object class. And not only that, unlike association, you don't have to step into another object to get to them. They are literally on the surface of the derived class. Circle class methods only have access to public members of geometric object. This is one that we haven't talked about yet. So, circle does not have the ability to say, I just want to modify stroke color. Give me that. It's like, no, slap, it's private. Right? Now, this is actually where another keyword that we don't talk about a lot comes in, called protected. Protected is, if I'm remembering correctly, private outside of the inheritance tree, but public inside of it. I believe that's what protected means. I'd have to look up. I probably should. So, the geometric object must be accessed through its defined interface, the same way that you would access it from, like, the main method, right? Circle still needs to go through the methods. Make sense? This is good design. You can't like privilege circle like that. Good. And once I get to the end of this list, I have a C++ joke to tell you. Subclasses have to use getters and setters, as I just said. The two-string methods in circle and rectangle override the two-string method in geometric object. Note the use of the optional override tag. We will discuss this in greater detail during our next class. It's unfortunate that we missed one this week.
Question? Yeah, we do come across no C# at some point in this program.
Yeah, no, you won't do C++, unfortunately. To a great degree, C++ kind of like wrote the book on a lot of these types of abstraction mechanisms, or at the very least, it popularized a lot of it.
I have to say, Java did nothing for us, because I started previous September, and it was the whole ChatGPT for Java thing for us. And
For Java, I thought
I mean,
Python.
Python, yeah. So it's like, there was nothing there. Like, I can't say I know Python.
Well, if you want the God's honest truth, Java is a better language to start with anyways, because it doesn't train as many bad habits as Python, because it's got a type system.
Okay. The
Right.
Python, I don't, maybe it's because I don't know the level of like I'm not advanced in it enough to know how there's a lot of people preferring Java over Python, but I think Python is pretty complex, right? Especially like if we just want to talk about the print.
Like, For a working man's language, Python does quite well. But if you're learning how programs work, you should learn Java. Now, you guys want to hear my C++ joke?
Yes.
All right. So, this situation where we were talking about one of these classes not having the derived class can't access the private members of the base class, right? In C++, you actually are given a way around that, and that is you can declare friendship between two classes. You can say, class A, you are a friend of class B. By the way, in C++, friendship is one directional, which is kind of funny. So you can say, class A, you are a friend of class B. What does that mean? It means that class A can access the private elements of class B. So basically, C++ contains an implementation of friends with benefits, because friendship means you can touch someone else's privates. And there's my joke. All right, I'll dismiss class on that note. Thank you very much, everybody, for your time and attention, and I'll see you on Tuesday.